Hello again, astronomy fans. Steve Duffy coming to you from Robert Ferguson Observatory with another lesson on the SkyX software. Tonight we're going to try to learn how to do auto-guiding and autofocusing. So to start off with, I've gone to the display menu and I've opened the focuser and the auto-guider window. And those are these tabs here on the side. So if we look at the focuser window first, we'll try that. If you're doing this at Robert Ferguson, before you attempt to autofocus, you must start up the Arcos TCC software. That is in the taskbar at the bottom of the window, or it's also in the startup menu. Anyway, once that's done, first thing we have to do, the telescope is all set up, it's all been synced and pointed and all that, and it's ready to go. So what we need to do to focus is find a reasonable star near our location. So what I'm going to do is go to the camera tab and go to the focus tools tab here. Then I'm going to choose at focus 2. Oh, before I do that, I want to check that my filter wheel is at the right filter. So it's currently at luminance, that's perfect. Back to camera tab, at focus 2. Now, these values are all preset. The one thing that you may want to uncheck is automatically Slew tells you the nearest appropriate focus star. So I'm going to say yes, I want to do that. For my telescope, the exposure time, 5 seconds is too long. Let's call it 1.5 seconds. So it's found a star, it's moving the telescope, it's taking a picture. Now we want to turn on graphs and watch what happens. So what's happening is it's moving the focuser out of focus at the low end. So it'll take a series of pictures at each focus position, and you'll see down here that it's plotting a V curve. The star will get smaller and then it'll get bigger again. So we'll just wait for that to happen. So it's pretty close to the bottom of the V right there. It'll come back up the other side. And here it says it was successful and it's moving to focus. So over on the focuser tab, it's added a new data point. Current temperature is 9.6. It's added a new data point right here somewhere for the luminance folder. Important thing here is to have this box unchecked. If you check protect current data model, it won't add any new data points to the model. So I've added that new point. It looks like it's lying on the line somewhere. That's great. So now I'm going to activate the temperature compensation. So I already know for my scope that it's 34 steps per degree C, and I have it change every half a degree. So that is that. It's focused. Now I have previously done that for every single filter, and so I've got filter offsets, you see them here, for each of the 5 filters that I have. And when I change filters, those offsets will automatically be factored in to the new focus point. Okay, so that is autofocus in a nutshell. And we are done with that. So now we need to pick a target and then try to auto guide. So we'll do Manage Observing List, Tools, Manage Observing List, and we will open Bright Objects Visible Now. And I'll run that query. I'm not sure that that's exactly the query that I want, but let's see what we can find. Several open clusters. Here's an open cluster with a reasonable magnitude and a reasonable altitude. Let's try this. So close this query. And I will say, do a closed loop slew to this cluster. And you notice my orientation changed. I'm going to change that back to celestial sphere and get it to stand up straight again. So there's our open cluster. It's going to center it up because it's doing a closed loop slew. And that was just the first picture. And there, it's centered. So we're done with that. Now we go to the Auto Guider tab. And we have an exposure time of 3 seconds. We're on the focus tools though. We don't want the focus tools. We want to be on the Auto Guider tab. Still an exposure time of 3 seconds. Binning 1, all of that is great. We want to turn off subframe. And the reason is that we want to take a picture of the full field of the guide camera in order to be able to pick out a guide star. So close that window and we take a photo. It should come up here in a minute. Okay, so several good candidate guide stars. I'm going to pick this one and I'll tell you why in a moment. So I double click on it, you see it blink, and then I'm going to grab this little subframe rectangle and draw a subframe around it. So there's several criteria when you're picking a guide star, and one of them is that it not have anything of equal brightness nearby. So the subframe excludes all of these other brighter stars because the guider will jump to the brightest thing in the frame. So you want to make sure that you don't have hot pixels or anything in the frame that it can jump to. It stays on that star. The second thing is you don't want the star to be so bright that it's saturated. You want the light curve to come basically to a sharp point. That way the centroid is accurately determined. So we want a star that's fairly dim, but not real dim. So I wouldn't ever choose one of these little dim ones down here, but this one, this one, this one would all work. This one would not work because it's too close to the edge. This one is practically perfect. We're going to go with that. I'm going to tell it to auto guide, and I'm going to turn on graphs. Now put the graphs down here, I guess, so that you can see the auto guider picture. So you can see that it's zoomed in on that one star and it's just showing us the little subframe, and that's the only picture it's taking right now. So here we see the graph. I'm going to spread it out a little bit. So the blue line is the position of the mount, and you see its declination and right ascension. And the green bars are corrections being sent to the mount. So right now it's trying to find itself. It's taking out all the slop in the system, and you see that it's kind of oscillating back and forth. Oh, well, it lost the guide star. Not sure why that happened. Maybe a cloud blew over. So we'll just stop auto guiding for the moment. So before I can auto guide, I need to calibrate the auto guider because I've moved locations with this telescope. So I've selected a star down near the celestial equator and down near the meridian. So I'm going to kind of repeat the process here. Go to the auto guider, uncheck the subframe, take a photo, so there's some good guide stars. I like this one because it's isolated. Draw a subframe around it. And say calibrate. You shouldn't need to change these values for the main telescope, but let's see what happens. So it's going to move it in X and move it in Y, back and forth, and then if we're successful, it'll tell us that we got a good cal. Yeah, so that's what a good cal looks like. If you get arrows pointing off in crazy directions, it's not a good cal. And usually that's because you're not doing it right in this area here. So here's my recommendation. Now let's go back to our desired target. Let's go back to our observing list and find that thing again. And we'll do a closed loop slew. We should get because we're doing a closed loop slew, we should get an updated picture here in a moment. That's the first one. The second one should move it a little bit to the left. And we're good. Go back to the auto guider, turn off the subframe, take a photo, and we have our stars back. Pick this guy again. Draw a subframe around him and auto guide. The graphs back up. So we see our star and our guide graph, and this time I hope that it's better behaved. So the size of the green bar is proportional to the error. There's some background settings I don't think we're going to talk about, but basically you'll never eliminate all of this jumpiness, this bumpiness. What you're trying to eliminate is any drift. If the curve drifts downward on average or upward on average, that's what you're trying to eliminate. Or any glitches due to, let's say, a cable drag or some little mechanical thing that forces it off track. So now this is starting to guide fairly well. You'll see that it takes, I usually allow a couple of minutes for it to catch up to itself, to remove all the slack from the gears. And you'll see that this pattern over here, this is an XY plot of this data, and you'll see that it'll start to center on the center of this graph. Now if we've got the setup done right so that we know the size of the guide scope and the size of the pixels in the guide scope, this will tell you how much error there is in arc seconds. So this is arc seconds here and arc seconds here. And so you can see that our average error right now is 0.48 pixels or 0.86 arc seconds, which is pretty tight, pretty good guiding. And you see the curve is kind of flattening out a little bit. So I would be satisfied with that. One thing to watch out for, when you go to take a series of pictures, so over here we take series, down here you have dithering. Dithering is moving the guide camera 2 pixels. And so when it gets to the end of the picture, it's going to jump. You'll see a big jump in the guide. So let's do that, and you get to see one. So I'm just going to take a short picture here. 30 seconds, luminance. And we want, let's call it 2 pictures. Okay. So now we're going to take that series. And so the first picture will be I'm going to minimize this so you can see the picture come in. So up here we can track the picture being taken. There's some lumps and bumps in the seeing. That's not the dithering. Exposure is complete. It's going to tell us that it's downloading. You'll see it here in a moment. And now it's dithering. And you see the big jump in the guide graph. That is dithering, and it will come back. And it won't start taking a picture until it's back within a half a pixel. So there you can see it's now started again. So when you see that, you can see it in either axis or both axes. Don't get too concerned about that. That's intended. Dithering helps you get a better quality images in the end. Okay, so that is it for auto guiding. Seems simple. In practice, it's not always so simple. You saw me have some struggles, but we'll pick it up again next time. Thanks for watching.